Right, so array lists then are a data structure in Java, which these are actual objects. Now, I keep coming back and talking about objects. Objects begin with a capital letter. Objects usually have methods available within them. These methods are code which someone has pre-written, which allows us to make use of some functionality which that object exposes. So one of the outcomes which you will be assessed on in the foundation's assessment relates to the benefits of object-oriented programming. So you could mention the array list in that section. This is the short report which you've got to write after you've created the 4 mini programs. So what's one of the benefits of object-oriented programming is the reuse of functionality which someone has already written and created in order to make life simple for you, the coder. You can reuse someone else's code. Now, most applications which have been, which are used in industry, usually have lots of features, lots of objects which programmers have created to make life easier for future programmers. All the big organizations, JP Morgan, Morgan Stanley, all these guys, the Microsoft, Apple, anything which they create always makes use of objects which have already been coded before. And Java, you've been introduced to a few of these. The scanner is one such thing, an object which allows you to take input at the keyboard. You can take input at the keyboard in Java using streams, using something called input streams. And the scanner object wasn't always available. The scanner object came quite late on. And the same with any of the GUI objects. They're all objects which are kind of brought in, introduced to the Java world later on. In the early days of any sort of coding, everything had to be done from basic code, so very raw data, very raw kind of programming techniques were used until we had this object-oriented kind of wave of reusing existing things. And the array list falls into that kind of category. So it gives us an object which we can reuse to help us build structures and build code and programs, which in a way is going to help us to create applications a lot faster. So the array list class, then this is part of the java.util package. So we import this again at the start, just as you imported the java.util.scanner class, this needs to be imported. By importing it, what you're telling the compiler is that I will be making use of this class. I will be making use of this object in my code. Therefore, give me access to the class. The class, remember, contains Java bytecodes. It's not the actual code. It's not the source code. It's the compiled down to byte codes, a code which we bring in. So we introduce this, and that allows us then to use this keyword as a feature inside our programs. Array list inside these angle brackets, so we're using these kind of brackets, the greater than, the less than symbol. Inside the angle brackets, we place in a data type. So if it's an array list which is going to use strings, then we would use a string inside. And same on the right hand side with a variable that we're going to use for accessing that particular object. With any object in Java, we always use the new keyword. That's effectively what the new keyword does. New reserves a place in memory for this particular structure, that particular object that we're going to make use of. So we're creating a new array. In this example here, then, we are creating an array list of data type string, which means that this will give us a structure for holding strings. And here's an example with some more code. So array list, string array list, we're going to call the variable friends. We will build an array list, initialize it. It will be size 0. We don't give it any size. Remember, the difference with the array is that we gave the array a size, a number, telling us how big we want that to be. But the array list doesn't have a size. It can grow as big as it wants. We then use the add method. So at the end of the variable name, hit the dot key on your keyboard, and that will give you a drop down showing you all the methods. I'll demonstrate this in NetBeans and as soon as I've run through the kind of theory of the array list. Dot add, and then we pass in a string that we want to add to the data structure. This will add Cindy. And then if you want to retrieve the data from within the array list, we use get and to return back an element. So dot add adds the element, get brings it back in. Then there's other methods that you have available. Set will allow you to change a particular element at a particular index location, and remove to delete an element at a particular index location. Size gives us the total number of elements which are inside the array list. So here's another example of how we're going to add. So when we add, call the add method with the variable name. So this is how we're calling it, remember? So we've got friends is the name of the variable. Friends.add, we'll add that in. And each time you add, size increases. So when you do perform a get size, when you try to read the size of the array list, that will increment by 1 each time we add something on to the array list. Dot add, passing in a particular index, puts that data in that location and pushes everything else forward. So in most cases, you don't really want to put something into a particular location. It might become useful later on, but for our purposes, just now as an introduction, you probably won't need to push things into a specific slot. For example, in here, if you're adding, so if this was the array list, the names array list just now, and we performed a names.add 1, Anne gets slotted in between Emily and Bob. So if you see Emily, Bob, Caroline, we're pushing it into position 1. So the index array list starts at 0 index, so it starts at 0. Adding Anne into position 1 pushes the others forward 1. So they then become index 2 and 3. When you remove an element from a particular index location, if you're doing a removal, then everything else gets pushed backwards. So here Bob comes back from position 2 back to 1. So it automatically adjusts itself. It doesn't leave empty slots between the structure. Once you've filled up an array list, you can use what's known as an enhanced for loop, or we can use ordinary loops. An ordinary loop has that same structure that you've used up until now, the for. So for keyword, open bracket, close bracket, initializer, the Boolean check in the middle, and then the increment or decrement at the end. But if you wanted to just cycle through all the elements that are held inside an array list, then the enhanced for loop is great for doing this. And it gives you a bit of a less cluttered code. So this is lots of things happening within here, but here's a neater way to do it. If all you want to do is cycle through all the array list elements, then we declare a variable which we're going to use to pull the data from the array list. In this case, we call this name. It could be named anything. We know that the names is a string array list. So if we filled up the names, as we've seen here, so if that was filled up with all this data, and we simply wanted to cycle through the array list, pulling out all these names, then using an enhanced for loop in this format, name, this variable will contain the data. And this is again a for loop, so it's going to repeat and keep repeating until it repeats until size, names.size, but we don't have to specify it. If you look here, you had to specify it. So this for loop repeats until I is less than names.size. Effectively, what you're doing here is going through all the array list elements, and this enhanced for loop does it for you automatically without having to declare variables and doing this. So behind the scenes, it's being done, but you don't have to manually do it. So here's just a summary of array lists, then some of the various methods that are available. So declaration, this is how you declare it. You then use add. Now if you just did a system.out.println with the array list name, the variable name, then this would send out to the screen all the elements that are held inside the array list. Now this is in objects. If you go on to look at coding in more detail, then there is a toString method in objects. All objects have what's known as a toString, T-O, capital S, string. So names dot toString. If you ever go on to look at object-oriented coding, then object-oriented programming, when we create objects, we will always give an object the ability to stringify itself. And that basically means give me a string version of all the data that's held inside you. So if it was a person, for example, if you had a person object has first name, last name, maybe age, maybe employee code, or some other details held within that data structure called a person. Again, think of entities in your databases. So if you had a database entity called person with a number of fields, first name, last name, and so on, then all those fields sent out to the screen or stringified or turned into a string would be the toString method. And that's effectively what this is doing. So because the array list is an object, the person who's created the array list, the coder, which would be someone at Java, of course, someone that works for, I was going to say Sun Microsystems. Sun Microsystems did have Java, now it's Oracle that looks after it. So someone in, imagine it would be Sun Microsystems or someone there, which coded the array list before Oracle took it over. So someone there created the toString method for names. And that toString method just goes into each of the elements and sends these out to the screen. Then you've got your add, your remove, your set, and so on. And if you want to get a particular element, use the get keyword. So set and get, again, this is very much an object-oriented feature. Setters and getters allow you to set and get particular fields inside an object. So this is why the array list is using that same convention of a get and a set here. So set allows you to set a particular element at a location, and get pulls out a particular element. So .get, then this method would be using a return keyword, RETURN. If you recall, when we looked at methods, they had some methods are given a return method, which means that they return back something. If a method is returning something back, then we need a data type or variable of that same type in this format on the left-hand side, which will hold that value when it's returned. So names.getI returns back, this returns back something of type string, and we've created another variable here which holds that variable, holds that data, so that we can then use it in subsequent lines of code. So ArrayList then is really just, we create it as a variable. And once you've created a variable of data type ArrayList, then you can pass that backwards and forwards between methods as well. Just as we passed backwards and forwards integers and strings and so on, the ArrayList, think of it as a contained object, a box, which you can then pass as a parameter into a method and also retrieve it back using the return keyword, sending it back to us as well. So here's an example where there's a method here called reverse. It's been created, and this is taking a list of strings. So this method is called reverse. So public static, the format of this is just as a method, again, method signature. So public static, then the data type. This is a data type which will be returned back. Notice the return keyword, it's returning back something using the method reverse. That's the name of the method, and the parameter that's being passed into this method is something of data type ArrayList string. So this object comes into this method. The object, the code within this takes that ArrayList, reverses them all, and then sends them back. It's sent back through this. This is the return. This is the data type. This is the return data type, and that gets returned back. The result created as an ArrayList. Do the reversal and then send it back. So an ArrayList comes into this method, and an ArrayList is sent back from this method. But it receives a list of strings and returns back the reversed list. Okay. Now, at this point, it might be good. You don't actually need to use these, but just to show you that there are object versions of the primitive data types as well. So these are the primitives don't have capital letters at the start. Notice that these are all small letters, but there are equivalent object versions of these which can be used, and sometimes you'll see these in code as well. The object versions have methods associated with them, so they allow you to do certain things. For example, you can convert from if you take an integer, you can convert that to a string variable, or if you take a double, convert that to some other, using the methods which are available within that particular object. This concept of auto boxing simply converts, uses these are known as the wrapper classes. So when we declare an ArrayList, the ArrayList has always got to be created using the object versions of those types. We can't use the primitive types. So if I want an ArrayList to hold a whole range of integers, for example, then we can't use the small letter int. We have to use the object version of that particular type. So the example which I showed you up above, we'll go back, these were strings. So ArrayList, capital S, string. String's an object. We know that string's an object anyway. It has various methods associated with it. But if you are creating an array list to hold a number of integers, then we have to use the capital I integer. And when you retrieve back the value, you don't need to use a capital I integer again. You can use a small letter. So here, for example, if you've got an array list of data type double, capital D, and you retrieved back a value, then when you retrieve back the value, you don't need to create another variable of data type capital D double. This is what's known as the auto-boxing conversion rule within Java. So it automatically will give you the primitive value if you attempt to pull the primitive value out from that object. And these are known as wrapper classes. So these are wrapped around the primitive data types. Okay, I will kind of run through this just now. I'll skip over these rather and show you some code. Yeah, so the rest of these slides just kind of show you how you would a comparison between the array and the array list. So use an array if your array, the size is never going to change, and array list if it's an unknown number of input values, if you don't know how many input values you're going to use. So with an array, you have something called a length. With an array list, we have size. So there's two different things here. Okay, I will stop there, folks, and jump into some code now just to show you an example code inside NetBeans. So in Google Classroom, then I've posted this project. It's a NetBeans project called ArrayList Test, and it demonstrates the use of the ArrayList object in Java. I'm also going to run through and explain how the code works in NetBeans. This also uses a user-defined object called name within it. So the actual project then is about creating contacts or names and storing names inside an array list data structure, an unlimited amount of names, and then retrieving those names and displaying those names back onto the screen. So if I just, I'm going to stop share of this and I'll just jump into NetBeans now. So share NetBeans, NetBeans, go. Okay, so that's the project now opened up here. So if you were using the project from Google Classroom, it's a zip file, compressed file. So you need to bring it down into your computer, decompress it, and then open NetBeans, and then go to File, Open Project, then browse to that folder, and that's how you would open the actual project up. It contains two classes. Sorry, two .java files. So two files. One is the file which contains the main This contains the main class, the entry point. So public static void main is in here. And another class for creating a name object. So a name object will be used within the array list. So if you see here, the structure of this array list, here we're declaring a global array list. So this has been declared outside of any method. So declare the array list, public static, use the keyword array list. The import has been put in at the top. Again, making use of the new keyword. And when the program first runs, it calls show menu. And show menu just displays, it's the same kind of menu code that we've been working with. Gets the user's choice, displays a short message on the screen. The user can then enter names or display the names. So entry of the names into the system. So if you wanted, we could have just used string here instead. Or if you wanted an integer, it would be a capital I integer, if that's what you wanted. So if you want to hold just numbers, for example, let me just demonstrate that just now. So I would, if I wanted to create something which holds integer values, oh, I didn't copy it properly. I would have this here would become integer, capital I integer, and numbers. So that's me got two array lists now, two global array lists. If you wanted to have an array list, a globally available array list, which holds decimal numbers with a decimal point within them, then you would use the double keyword here, or double data type, capital D. Remember, this is the wrapper object, capital D for double. And this then means that my numbers can be used within some code. I'll just demonstrate it here, just in here. My numbers, hit the dot. As soon as you hit dot with an object, it shows you a list of the methods available. And here you've got the add available. So I can use add and add a number to that. So if I added number 23.4, for example, that would work. And this can then be used. Or if you wanted, you could use the scanner object and do a read of a double from the user using my scan. So I could just replace this with add. My scan has been declared up above, if you look here. So my scan dot next double could be used. Or if it's an integer, you would use next int in that case. Okay, so that's the numbers. Just I'm going to remove this from this screen now. Just give me 1 second. So that was my numbers dot add. And if you wanted to just directly take something from the keyboard and add it in to the array list, then this is how you would do that. So direct adding using next double or next int in that case If it's a string you want to add to an array list, it would just be dot next on its own, or next line that you would use. Okay, so I will hide this from here just now. We're not going to use this. And I'll also hide this as well. So if you were building your assessment program in this manner, then effectively you could use 2 or 3 separate array lists. So you would have an array list for each section and just use it that way. You don't need to have one array list to hold everything. You'd have an array list for each of those small programs. So memory size, I think, I can't recall the other ones, but it'd be an array list of data type, either integer if it's integers, or doubles if it was doubles that you're going to use. So show menu then starts this up, displays this message, displays enter names, asks the user to choose one of these options. And then depending on the option that the user chooses, we jump into the case statement and then prints out a short message on the screen. And then it calls this quite verbose method name. I've called this get names from the user at the keyboard. The more descriptive your method names are, of course, the easier it becomes if in months and months coming later, you want to maintain or add something to your code. It makes it very easy to understand the methods. So instead of just calling this get input, it's called get names from the user at the keyboard, and then display calls a method display the user's names. So that's the case statement finished up, and it exits on the choosing of option 3. So here's the methods. Get names from the user at the keyboard. So this creates a scanner. So if it was numbers you wanted from the user, you could call this get numbers from the user at the keyboard, in which case you would use a number. You just rename the method name, get numbers. So because this is names and it's strings that we're taking from the keyboard, I'm using .next. So .next is the method inside the scanner object, which takes a string from the keyboard and adds it. And then we add that to this variable here, which is of data type string. And I'm doing a check here. So the check here, again, because it's a menu-based program, I will continuously ask the user to enter these. Please enter a name. So this program works slightly differently. It's jumping into a loop. So the user will continuously enter a name until they enter a gate or hash symbol. And when they print the hash symbol, it will move out and close this menu entry and jump back to the menu entry. So each time the user enters a name, what I'm doing then is creating a name object. So a name object gets created in the same manner that we created ArrayList objects or scanner objects. We put the data type here, name obj, then the variable, followed by the new keyword, and then again the class. And the name object has some methods. It has a get name, it has a set name, and it also has a toString method, which has been created, coded within it. So the name object really is one that I have made up. just to show you this object-oriented mode and way of working. You don't need to do it this way. If you want, you can simply, you don't have to use the objects. This line here is the line that actually adds to the array list using this .add method. So that's the .add method from the ArrayList, java.util.ArrayList. So I'm using the add method, and that's the only part that's adding it. What I'm doing here is really just creating another name object and passing that in as a variable in to this array list, which is being created to hold name objects. And the code around it is really just code to kind of hold the whole thing, the whole structure together. To display the names that have been entered, we're using the enhanced for loop. This is not an enhanced for loop, we're using a bit of lambda code here, which is quite not something which you'll not cover if you go in a bit deeper into Java. So I'm using this. So you could use this to display all the names, but what this does is it pulls out each of the objects. You can, if you want to learn more about them, you can go and search lambda structures in Java. But you don't need to use them. You don't need to use this. You could have anything that you could use. So the previous slides which I showed you, you could use a standard for loop. You could use an enhanced for loop, or if you wanted, you can use this lambda function. And again, this is just calling the toString method on that element. The toString, remember I explained, just turns the object into a string for sending out to the screen. So let's have a look at the name object then. The name object class, it's a class, it's a separate file. It was introduced to the package by doing an array, a right click. So I right click on the package name, choose new, and then choose Java class. This adds an empty class into the project, which can then be used. So public class, capital N because it's an object. I set up some variables within that. It just has one state variable, so one which just holds name. If you wanted this to be a contact, you could add extra things in here. For example, if I wanted to add a telephone number, I could use private string telephone number or mobile. In fact, I could call it mobile. And anything else, any other things associated with this. In that case, nameObj might not be a good name for this class. I would then call this person obj, so person or employee or whichever variables you wanted to hold within here. So you could add those extra ones. This only contains one single variable, which is a name. There's a constructor, an overloaded constructor. Again, I understand that I'm not going into the great depths of object-oriented programming, but I will give you something that you can now go and maybe research a bit more of. By simply searching for these keywords. If you search for things like constructor, Java space constructor in Google, you'll get lots of resources on the internet that kind of explain this. This is not really an object-oriented programming course as such. It really is just an introduction to this just now. So default and overloaded constructors. This constructor, these two methods have exactly the same name, as you can see. And that name is always the same as the class. So this is the class name, the constructor name, and any overloaded constructor names. These are always the same name object. They just differ. So that's the default one, doesn't have any parameters. The overloaded one here has parameter. Then you have your accessor methods or your getters and setters. So to get name, set name, and then the toString method, which has been overloaded as well. Okay, enough of code then. Let's have a quick look at how this runs. So let's run the program. So the menu displays this. I'm going to choose 1, enter names. Names entry feature opened. Please enter a name. So I'm going to enter a name. My name in, press the enter keyword. It says, give me some more. And each time I press enter, it's asking me for more. Enter the hash symbol to finish name entry. So I press the hash symbol, and then it takes me back to the main menu here. So now what should have happened by me entering all those names, then the array list data structure would now contain those, it should contain that data which I've entered. So choosing option 2 would allow me to now run the code, display the users' names. So this bit of code here, which I'm highlighting at the top here, calling this function, this method, this lambda call, cycling through this collection of name objects inside that array list. So let's run it. So choosing option 2, press enter, and it's printing out name is, followed by a retrieval of the actual string, actual name from the array list. And that this name is part of the class where we have the overrided, I've overrided the default toString method. Overriding basically means I've given it my own customized toString, and the customized toString adds this in to the name is part as well. And this is just a reference to the actual object. So this name is a string. Notice this padlock here. This tells me that this name can't be retrieved. It's a private variable, and it is private because I've set it to private here. So the array list test can't access that name. It can't access that name variable, but it can access the public methods. So anything public outside of this class is accessible. So hence, this is the reason why we have certain things as public and private. There's also another one called protected, which is only used by inherited classes, but again, that's another story for another day. So right now you're seeing private variables. These cannot be accessed outside of the class, but the public methods and the public data can be accessed outside. So that toString is public. Therefore, when we come in here, we can call element dot toString. That's available. Set name is also available. Get name, again, that was a public one as well. But notice name is not public here. I can, just to demonstrate it, I can make that name. But we don't set these. Generally, we tend to always have the state of an object is always private, because you don't want something to come in and modify this on the outside. If I now go back to, I'm changing that to public, it's now available. You see that? So now name has become available because it's a public, it's been set as public. But we don't want to be able to modify these things. And the reason why we keep the variables or state of an object set to private is in case of corruption. We want to give access, hence the reason, hence why that's why these are called accessor methods. We want to give access to the name only via the accessor methods, the getters and setters. That's why we have these public methods get name, and a public method, set name. Inside here, we can do various if things, if statements, for example. So say you had a set name and there was a rule, for example, that said the name must be greater than 0 characters. In that case, you could have an if statement, if, do a check, if the name, if the, if the name dot length is greater than, let's say we had a rule, for example, that you can't put in names that are less than 3 characters long. So you can't have a name which is 2 characters. If the name dot length is less than 3, or let's say greater than 2, only then allow the names to go in. Then we place this inside this if statement. So that's the reason why we have these methods and accessor methods. They allow us to filter the data that goes in to these. We filter the data that gets used to set these using if statements. I'll run through this code once more. This time I'll run the debugger just to show you how that's working. So this is, I'll leave this in just now. I'll leave it in just now. So let's run this again once more with the debugger. So this time I'm debugging. Check the output. So enter name 1. Oh, I should really add a breakpoint in there somewhere. In fact, maybe I don't. I can still see, I can still watch the variables because there'll be certain points this will stop, this will pause anyway. So names entry, so I'll enter in 1, 2, 3. So 3 entries have gone in. Let's go and have a look at the variables. I can add variables that I want to watch in here. So my numbers, loopy, no, don't want those. What's it called? So my name's array-based database. That's where that's the variable I was using to hold those names. So if let's add a new watch. So I want to watch my name's array. So I want to watch this. Yeah, I need to stick a breakpoint in, I think. Let's just stop it. So during the entry, so create the object, adds, stop. I'll pause it here. So I'll stick a breakpoint here. Debug. 1. Names. As it stopped, paused, but I'll run it forward again. So F, step over, F8. So I'll run it forward, F8, and F8 again. So it's waiting for another name, so I'll put another name in. And F8. And now we'll go and have a look at the array list. So it's telling me that the size is 2. You can click on this plus sign, take a look at the entries, and just expand and keep expanding it. So this is containing a string here. string here. So it's actually containing element 0 then inside that array list contains something of data type nameObj. A nameObj has one variable or one state data field within it, which just contains string, and the second one again contains the second name. Okay, so that's useful to see if you're building your array list, and if you find that your array list is not actually taking any entries in, then just use the debugger to stop it and see what's happening within it. Okay, let me stop that just now. I'll remove this. And just stop sharing. Just going to stop recording just now as well, folks, just see if you've got any questions for me.